So we're told that S is 900, so P plus 900. And then down here, I'm going to have P. R is given as 1.1. So 1.1 minus 1 would be 0.1 P minus 900. Well, the numbers are messy, and we could decide whether we wanted to worry about the fact that the numbers are messy or not. I'm just going to move forward with the messy numbers. So if I look at this, the first thing I'm going to check for is it possible that there's a U substitution here? If I were to distribute that P in on the bottom, I'd have 0.1 P squared minus 900 P. And if I took the derivative of that 0.1 times P squared, I'd have 0.2 P minus 900, which really looks nothing like the numerator. So it's not a U substitution. Since it's a fraction, I'm going to think about where's my biggest power of P. The biggest power of P is in the denominator if I were to multiply that out. And since the biggest power of P is in the denominator, my next thought really is partial fractions. So I'm going to have P plus 900 over P times 0.1 P minus 900 is equal to A over P plus B over 0.1 P minus 900. So thinking about this, once we multiply out both sides, once I multiply both sides by that common denominator, I'm going to end up with P plus 900 is equal to A times 0.1 P minus 900 plus BP. Since I did the previous problem by plugging in numbers, would anyone like me to do this one the other way, where we match up coefficients? Great, I saw some yeses, so let's do this one the other way. By the way, I personally probably wouldn't do it by matching up coefficients, but just so that we get to practice and see both methods. If we're going to match up coefficients, then the next step is to multiply out everything on the right-hand side. So I've got P plus 900, and then distributing my A, I would have 0.1 A times P minus 900 A plus BP. So the idea with matching up coefficients is that if this equation holds for all values of P, then any term on the left-hand side with a P has to match the terms on the right-hand side with P's. So that 1P has to equal 0.1 AP plus BP. Or if I don't worry about the P's, that says 1 is equal to 0.1A plus B. The other part that I have in the left-hand side is this 900. Since that 900 doesn't have a P attached to it, this has to match up with anything on the right-hand side that doesn't have a P attached to it. We got lucky this time, and this one practically solved itself. I now know that A is -1. And if A is -1, then we should be able to solve for B pretty quickly. If A is -1 and I add that over, then I'll have 1.1 is equal to B. Just like with the previous problem, solving for those constants, that's kind of just our first step to integrating. Now we actually have to do the integral. I'm erasing slowly just in case questions come up in the chat. Put this up here, B equals 1.1 I think I'm going to squeeze it in right here. So we're swapping out this original integral for these two. So our a value went over p, meaning I'm going to have -1 over p. And b was equal to 1.1, and that goes over this other term, so plus 1.1 divided by 0.1 p minus 900 dp. Since both of these are a constant over a linear term, they're both going to end up being natural log. So this one, I'm looking at negative ln absolute value of p. Here, I'll have that 1.1, the constant from the top, times natural log of that linear term in the denominator, divided by 0.1, again, to correct from the chain rule that would have happened if we were taking the derivative. This is how we're correcting for that when we find the antiderivative. And that would be plus a constant. That's our relationship between p and t. And we were explicitly told to not try to solve this for a p-value.